Hello everyone. In this lecture, we will study the reactions of epoxide. Reactions of epoxide. Now, the ring opening reactions of epoxide by nucleophile. The ring opening reactions of epoxide by nucleophile. When the nucleophile is attacks on the epoxide, then that time the ring is open. Okay. Now, the first reaction is the reactions of epoxide in acidic conditions. The reactions of epoxide in acidic conditions. That means the epoxide is a reacts with the acids. Okay, is a reacts with acids. Now, the epoxide have a tendency to open the ring. The epoxide have a tendency to open the ring because in this ring, the one heteroatom is a present oxygen, and oxygen is a more electronegative than this carbon atom. Okay, now epoxide have the tendency to open the ring because this oxygen which withdraw the electron density from these carbon atoms. Okay, the oxygen atoms combines with the hydrogen. Now suppose here this ethylene oxide is a reacts with the HA. HA is a general acid, means like that the HCl. Okay, HCl. This hydrogen is carries a partial positive charge. Chlorine carries a partial negative charge. Okay, so H is a partial positive and A minus is a partial A is a negative charge. Okay. Now the oxygen atoms combines with oxygen atom. This oxygen atoms combines with this hydrogen of any compounds. Okay. This oxygen atoms combines with hydrogen of various compounds, then to form the hydroxyl group. Then to form the hydroxyl group, OH group. Okay. Then to form the hydroxyl group. Then to form the here the addition product is formed. Addition products means this oxygen is a combines with hydrogens of various compounds, then to form the hydroxyl group. Then to form the hydroxyl group. Now in these reactions, the ethylene oxide is a reacts with the HA, then to form the this addition product. Okay, here the ring is open. Okay, now this A is attacks on this CS2 group. Okay, electron depletion in this carbon atom, and this bond is a break in this direction. This bond is break in this direction. This hydrogen is attached to this OH, then to form the CS2 CS2A. A is attached here to this CS2 group. Okay, and this hydroxyl group is attached to this CS2. Okay, then to form this addition products. Okay, this is a first. This is a ring opening reaction. Now the hydrolysis of epoxide. The hydrolysis of epoxide. The ethylene oxide, that means epoxide, is undergo the hydrolysis in the presence of the acid. In the presence of acid, then the formation of the glycols. Then the formation of glycols means dihydroxy alcohols. Di means two hydroxy alcohols. This two hydroxyl group is attached to these two adjacent carbon atoms. Okay, that is called as the ethylene glycol. This is ethylene. Okay, CH2 CH2 ethylene glycol. Okay, they are the two hydroxyl group which is attached to the two adjacent carbon atom. Then that is called as the ethylene glycol. Okay, this reaction, the ethylene oxide is a reaction with the undergo the hydrolysis in the presence of the H plus, then the formation of the ethylene glycol. Now ethylene oxides when heated to 50 to 70 degrees Celsius. Ethylene oxide when heated to the 50 to 70 degree Celsius with the largest with large excess of water in the presence of acid. Excess of water is a use here. Okay, excess of water is a use here in the presence of the acid catalyst like the HCl, H2SO4. Okay, it adds a molecule of water. It adds a molecule of water to give the ethylene glycol. To give the ethylene glycol, and this is called as a hydration. And this is called as a hydration. The ethylene oxide, when heated to 50 to 70 degrees Celsius with large excess of water, presence of the acid catalyst HCl and uh, sulfuric acid. Okay, it adds a molecule of water to give the ethylene glycol. Means that is the ethylene oxide is reacts with the water in the presence of the acid. Then the formation of the ethylene glycol. This reaction is called as a hydration. This reaction is called as a hydration because you have the addition of water. Okay, the resulting solution is concentrated up to 70%. The resulting solution is concentrated up to the 70% by the evaporation, by the evaporation, and by the fractional distillation to get the ethylene glycol. By the fractional distillation, then to form the ethylene glycol. The excess of water, the excess of water keeps the formation of polyglycols. The excess of water keeps the formation of polyglycols to minimums. The excess of water keeps the formation of polyglycols to minimum. Now the side reaction here. We suppose in the first step you prepare the ethylene glycol. Okay, ethylene glycol. Now again this ethylene glycol again is a react with the ethylene oxide. Again reacts with the epoxide in the presence of the acid. Okay, in the presence of the acid. Then again the formation of the diethylene glycol. Diethylene glycol. In the first step, you prepare the ethylene glycol. Okay, that is a ethylene oxide is a reaction to undergo the hydrolysis in the presence of the acid. Then the formation of ethylene glycol. This ethylene glycol, suppose again reacts with the epoxide. Okay, then the formation of the diethylene glycol. That is a formation of the excess of water keeps the formation of the polyglycols. Okay, now the another reaction is that the epoxide is reacts with the HX. HX means the hydrohalogen. Okay, X is a halogen. Okay, halogen acids. The epoxide is a reacts with the halogen acid. The epoxide is a reacts with the halogen acid. Then to formation of the halohydrin. Halohydrins. Halohydrins means halo means halogen and hydrin, that is a OH. Okay, OH, Cl, OH, Br, like that. Okay. Now the epoxide, ethylene oxide, is a reacts with the HBr. HBr. Okay, hydrobromic acid. Okay, the ethylene oxide is a reaction with the HBr. Okay, then the formation of this Br carries a negative charge, the hydrogen carries a positive charge. This Br is attached on this CH2 group. This ring is open here, the and this oxygen is attached to this hydrogen, means this OH and Br. Okay, so bromine is attached to here, this CH2 group, and the hydroxyl group attached to here. Okay, then that is called as a halohydrins. Okay, so what is the name of this compound? That is a ethylene bromohydrin, ethylene bromohydrin, or there's a 2 bromo ethanol, 2 bromo ethanol. Okay, very simple. The ethylene oxide is a reaction with the HBr, then the formation of ethylene bromohydrin or 2 bromo ethanol. Now another reaction is the ethylene oxide. This epoxide is a reaction with the HCl, hydrochloric acid. Okay, then the formation of, again same mechanism, the chlorine is attached to this CH2 group, and this oxygen, this lone pair is a attack on this H plus. Okay, electron depletion of hydrogen, then ring is open here. Okay, then the formation of the chlorine is attached to this one first carbon atoms. Okay, now the ring is open here. Now what is the name of this compound? Ethylene chlorohydrin, ethylene chlorohydrin, ethylene chlorohydrin. One first two chloroethanol, 2-chloroethanol, 2-chloroethanol. What is the name of this compound? 2-chloroethanol. Now the third reaction is the epoxide is a reaction with the hydrogen cyanide. The epoxide is a reaction with the hydrogen cyanides. When